Hello, and welcome to Gren and the Road to 1.0. In this video, I'm going to talk about how Gren ended up where it is today, but also what will happen in the next couple of years and see where Gren is headed. And I'm going to do this in order to answer two of the most common questions that I get. One, why does this particular feature work the way it does? And two, when can I expect to use Gren in production? I'm not going to talk too much about what Gren is and what problem it's trying to solve. If you want to know more about that, you can check out this Developer Voices episode where I talk more about those kinds of things. What is important that you know for this particular video is that Gren started as a fork of Elm. And the main reason is that I was starting to do more and more back-end work, and Elm is really a front-end first programming language. You can definitely do back-end development with Elm, but it's not meant for that. It's not built for that, and it's going to be a little painful. There are two more things about Elm that has irked me for some time, and that is it's in certain regards not quite finished, right? Elm itself is not a 1.0 language, and in certain areas that shows. And so I wanted to kind of like see if I could take something like Elm and finish it from my point of view. And the third thing that bothered me a little bit about Elm is that it doesn't really integrate with the existing dev tools that we have as web developers, like the debugger, like the profiler, and all those kinds of things. I'm going to also touch more into that in later videos. Later on in this video. But the most important part is that I wanted a language that does for backend what Elm did to front end. I wanted a backend language which is as beautiful to work with as Elm is for front end development. So I began work on Gren December 2021, and a couple of months later, or 6 months later, Gren 0.1 was released. One of the first things that I did to Gren was to remove the reactor and the GLSL syntax. Now the reactor, for those who don't know, is a development server built into the Elm compiler. I have never used the Elm reactor, at least not for anything other than demonstration purposes. And I didn't want to maintain it moving on. Essentially, like if I don't use it and don't depend on it in any way, I don't want that to slow down my development of the language. GLSL, essentially the same rationale. I don't know, like GLSL is the shading language for the WebGL standard. I've never written a WebGL program in my life. I definitely don't know what shaders are, and I didn't want to maintain it moving forward. I don't have anything against the feature per se, but I'm the last person who should maintain that feature. And so I made the decision to remove it. Another more interesting removal is automatic constructors for type alias records. So in Elm, when you create a type alias and you point that type alias to a record, it will create a function with the same name as the type, which essentially allows you to construct a record using what I like to call positional semantics. Like if you define a record with a name string and an age int, and you type alias that as a person, calling the function person with a string and an int will generate that record for you. In Gren, that constructor is not generated anymore. And the main reason for that is because it actually was a bit confusing. It doesn't really fit into the language. Like if you create a type alias of a record type alias, you don't get a constructor. If you create a if you create a type alias of any other type than a record, you don't get a constructor. So it was kind of like, it was a feature that wasn't really consistent in the way it worked. And when you use automatic constructors like this for JSON decoders and the like, a lot of people new to Elm kind of view it as special syntax. Like decoders has special syntax. You you put in the type and then you do some other shenanigans and then it builds the decoder for you, when in fact it's just functions all the way down. And I could talk more about the reason for that. That's the gist, right? It was a feature that looked like magic for beginners and which wasn't consistent from a language point of view. So it was removed. Tuples have also been removed. This happened really because after having written a lot of Elm programs, I've consistently been bitten by tuples. Tuples are a very, very seductive feature in that it's very easy to use it, and it's very easy for a tuple to become part of your API. And the problem with tuples becoming part of some API is that if you add something to a tuple, you've probably broken everywhere in your application that makes use of that tuple. If you reorder the fields of a tuple, you've broken every single part of your program that references that tuple. And so tuples, to me, is an anti-pattern, especially from the point of view of refactoring. The compiler will always tell you where your code is broken, but by using tuples, I found that I broke my code unnecessarily way too often. And so I ended up just using records instead and didn't have as many issues when I did that. And to kind of atone for removing tuples, I improved pattern matching of records. So I'm going to show an example of that, but pattern matching over records is easier in Gren than Elm. Gren also uses JavaScript arrays as the default sequence type. So when you place something within brackets, Gren will actually compile that into a native JavaScript array instead of a linked list as in Elm. And part of this is simply to better integrate with the environment that we're targeting. So both Elm and Gren targets JavaScript. We output JavaScript code. And when we output JavaScript arrays, the JavaScript engine will recognize that and have special optimizations for it. Elm's linked list will seem like a nested series of objects through JavaScript engine, and so it won't be able to optimize that as well. But perhaps more importantly is that this carries over to development toolings and profilers, right? Those things can also not understand that this is just a list sort of thing. And I'm going to show you an example later on how this plays out. But yeah, the switch from linked lists to actual arrays was in part made for performance and integration reasons, integration with the platform, that is. And finally, when you're making a new language that doesn't have a goal to be compatible with the language you base it on, you need a new package manager. You can't, like the Gren compiler can't compile Elm programs, so we can't make use of the existing package manager. And so the package manager in Gren was rewritten to use Git directly. And there are some downsides to this. There's also some benefits. So first of all, Elm is a language that is tightly integrated with GitHub. If your project isn't on GitHub, it can't be used as a dependency in Elm. And in Gren, it's pretty much the same thing. And so by using Git, we don't actually lose anything from the perspective of Elm, right? You still have to publish things to GitHub and tag it accordingly in order for it to show as dependency. But by using Git directly, we kind of like, so the compiler actually uses your installed version of Git. And so if you have access to a repo, then the Gren compiler has access to that repo as well. So if you have a private repository, you can use that as a package in Gren. In Elm, you can't. Of course, the downside by using Git is that a Git clone is slower than HTTP request. But other than that, it's not that different. Now, I promised you an example of how pattern matching on records have improved, and here it is. This is valid Gren code. This is not valid Elm code. You can't do this in Elm. But essentially, the way we essentially what we do here So in Elm, you can use tuples to compare two things in a case expression, or pattern match over two things in a case expression. In Gren, you don't have tuples, so you have to use records for the same thing. So here we create a record where left equals A and right equals B, and then we pattern match on that record, and essentially saying that if both left and right are false, then return the string stop. If only left is true, go left, and if only right is true, go right. And this works the way you expect. This performs exhaustiveness checking and the like. So this is exactly equal to using a tuple. In fact, the exact same code is being generated here. It's a little bit more verbose, but in general, you don't really lose any functionality. In fact, you gain some functionality because you can pattern match this way on records, you know. So that was the Gren 01 release. In December that same year, which is roughly 6 months later, Gren 02 came, and this is where things started to get interesting. So in Gren 02, you could actually compile applications that did not expect to run in a browser, but could run in node.js. I'm going to show you a demo on that very shortly. But that was like the big thing in Gren 02. It was our first step on delivering on Gren as a backend language. In addition to that, Gren also got a few more commands for managing dependencies. This was also a sore point in Elm and based on things that felt unfinished to me. So in Gren 02, you got commands for uninstalling a package from a project, for getting a list of outdated dependencies in the project, and for updating dependencies in the project. Certain error messages was also improved. So instead of getting an error message saying something is wrong here, you would get an error message saying these two packages are not compatible. Consider removing one of them or updating the other. Another language change that happened in Gren 02 is that you could perform record updates on any expression and not just variables. Again, I'm going to show a small example of that later on. And finally, multi-line string syntax was changed so that, well, in Elm, when you define a multi-line string, indentation is preserved. So if you have a multi-line string and the string it doesn't start from column 1 of your file, the indentation is carried over in the string representation itself. In Gren, starting from the 02 release, multi-line strings works the same way they do in Java, where leading white space per line is removed. All right, so that was the main ticket items. I'm now going to show you an example of how you can create a Node.js application using Gren. So so here is the cat program from the example repos project. This is the Gren JSON file. And you can see it looks pretty much like an Elm JSON file with one exception, and that is that you can now have a platform node. If you're targeting a browser application, you would have platform browser here. But this is a node-based application. And the functionality for the node for node APIs you can see here in the dependencies list. So here we include Grenlang node as the dependency, and that provides APIs that we need in order to create Gren programs. So the cat application is a program that takes a file name as an input and essentially just prints the content of that file to the terminal. So we start by defining what a program actually is, and that's the main definition. And then, this should look very familiar to anyone who's written Elm applications. You have an init function that returns the initial state of your program. Then you have an update function that updates the state of your program given a particular message or event. And then you have subscriptions where essentially you can listen for certain things to happen and then do an update whenever that occurs. So I'm not going to explain this in detail, but I'm just going to run through it. So an interesting thing about node.js applications in Gren is that they work with the idea of subsystems and permissions. So when you're starting up a Gren node application, you have to define what sort of functionality you are intending to use. So we're going to spin up the node system. That is going to give us a node configuration value. And that value is going to contain references to the standard out stream and the standard error stream. We're also going to wait for the file system to initialize, which is going to give us a file system permission. Now, these stream values and this permission value serve two very important functions in Gren. And what's important to mention is that when you initialize something, you are allowed to return a value, which is called an app initialization task. And that initialization task can only be returned for applications. So if you're writing a Gren package, you can create an app init task, but you can't run it. And if you can't run it, then you can't get the permission value. You can't get this node configuration value, which means that you have no way of retrieving references to the standard out stream or references to the standard error stream, or even the FS permission that you need in order to read files. The only exception to that is if the application hands those values over to you. So in Gren, you can be pretty certain that if you did not pass a file system permission to the function of some package, that package has no way of running file system operations. If you did not pass in the standard out reference to a package, that package has no way of writing to standard out. And so this is a very, very powerful concept. It requires a little bit extra code, but it gives you a lot of control of how your application works, what sort of side effects can happen where. So that is very interesting. Now, in this program, we're going to attain these permissions. We're going to store references to standard out and standard error, and then we're going to read the arguments passed to the function. We're going to read the third argument, which is the file name. The first two arguments as per, and this is also the case for Node, the first two arguments is the executable that is running the application. Typically, that will be Node. And the second argument would be what is the file name, which is your actual application name. And then the third argument out is what are the arguments. So we're going to read the third argument, which is the file name. And then using that file system permission, we're going to open that file for reading. Once that has happened, once this has happened, we're going to get an open result. And either we're going to get a file handle, in which case, which means the file is open, you can read. Then we can actually try to read the file. If it failed, we can write an error message to the terminal. And once that file has been read, we should have a list of bytes. And in this case, since this is the cat program, we're just going to stream all those bytes out to the terminal. So it's a simple program, but it illustrates, or, you know, it's fairly complex given what it does, but it illustrates the concept of streams and permissions. And of course, as you know, this boilerplate is init and update function. As your program gets larger, this overhead gets smaller and smaller. So this example is relatively complex given what this does, but it also shows the amount of control that you have over normal code, really. All right. So that was a demo on how you can write Node.js applications in Gren. Another thing that happened in the O2 release was being able to perform record updates on arbitrary expressions. All of the examples on this slide are valid Gren code, but they're invalid Elm code. So in Elm, you could not really perform record updates on any expression other than a variable reference. While in Gren, you can perform a record update on any sort of legal expression that includes function calls, nested record references, and even, you know, records, even qualified references. Now, the main reason this did not exist in Elm, from my understanding, which could very well be wrong, but from my understanding, the two bottom lines of the slide is the reason for why record updates on arbitrary expressions are not a thing in Elm. If you were to look at the sum.record update expression, you might think that that would update the sum record and sum.record to reflect the current state, to reflect the new state that you want. But actually, in Gren, that will, you know, first we evaluate sum.record, which returns the record pointed at by sum.record, and then we update that. If you want to update the entire thing, like if you want a new record, which contains an updated reference to that nested record, you have to perform 2 record updates. And this might not seem intuitive, but you know, the rule is actually pretty clear here. But in any case, that ambiguity, to my knowledge, is why the feature was left out, that it could be confusing to beginners. Well, it could be confusing. Personally, I view this as, you know, if you just define how it should work, then people will learn it, no matter how confusing it is at the beginning. And I also think that, you know, in most other cases, we don't have limitations like this. Like, we don't limit what can happen between if and then in an if expression. We allow any arbitrary number of nested case expressions. You know, so I think here I've just defined that whatever's on the left of the pipe operator, that is an expression, and as long as that evaluates to a record, you can update the record. So in Gren, all of these cases are good. So that was Gren 02. In Gren 03 was released in June 2023. It brought support for local dependencies, and by local dependencies I mean dependencies you have on disk instead of on GitHub. It also brought support for sourcemaps. It brought a test framework, and by that I mean we ported the test framework for Elm over to Gren. And a little bit after the release, we brought support for creating HTTP servers and calling Unix processes. So local dependencies, they look like this. So this is a Gren JSON file, and if you look at how the Grenlang core dependency is defined, you can see it actually references the parent directory. And so here you can include your very own Grenlang core dependency. And in this particular case, this Gren JSON file is taken out from the test project, which is the application that contains the tests for the core package. So to define tests, you include the test framework and a package for running said tests in Node, and then you reference whatever package you want to test. In this case, it's Grenlang core, and then you have the tests as part of this application. I felt I was talking a bit in circles there, but I hope that was clear enough. The point being, you can actually include packages that you have on disk as part of a project, and that makes it easier to test a package before you publish a new version, for instance. But in this particular case, we use it for defining and running tests. Another big feature is sourcemaps. So this is a screenshot from, I believe it is Chrome DevTools. So here we've taken a Gren application and we have compiled it with source mapping enabled. And that allows us to view the actual Gren source code of the program and debug it. Here you can see we've set a breakpoint, and if we run the application, it will stop there and allow you to kind of like step through your code. You will also see on the right that those are the variables in scope, and small range is an array, right? And the reason it shows up as an array is because in Gren it is an array. It is a JavaScript array. In Elm, this would instead look like nested objects. And as long as you know that, then that's fine. Like I've debugged a lot of Elm code, and so I'm able to make sense of it. But this is more intuitive. Like this is how JavaScript expects it to look, and it has built-in stuff for the debugger, which makes life a lot easier. You can see we still have a long way to go, though. You can see in the call stack, there are a lot of anonymous function references and some unreadable names. And we hope to improve that in future versions. All right, so that was the changes introduced in Gren 03, which was released in June of this year. And that represents the status quo. That's how far we've gotten with Gren since its release. But we're not stopping there, and currently I'm working on Gren 04, which will be released in December. At least I'm hoping to be able to get it in shape for that. And the big thing in Gren 04 is parameterized modules. And parameterized modules is a feature to solve a similar sort of problem that interfaces or type classes or protocols solve in other languages. But it hopes to solve that problem without encouraging very abstract code and without the problems associated with a global implementation namespace. So Elm almost famously doesn't have type classes. Well, or actually it has 2 or 3 type classes, but you're not allowed to define your own, and you're not allowed to extend implementations of those built-in type classes. And I think the main reason for that is that the sort of abstraction you see in languages like Haskell and to some extent even Java is quite confusing, especially if you're new. And it makes it very uncertain how certain things work and fit together. And so in Elm, you will see that there are a lot of concrete implementations, and that's not a consequence of bad language design. That is intended. Elm very much sees it as beneficial of using concrete implementations as much as you possibly can. And in Gren, we see the benefit of that, right? Code, I believe, essentially becomes simpler the less abstractions are involved. And so when looking for a way to have like a hash map that can work on any type, or a dictionary that work on all comparable types, I try to find a solution that doesn't encourage too much abstract code, because I really like the clarity the lack of certain abstractions brings to Elm code. The second point here, the problems associated with the global implementation namespace. So in Java, this is actually quite simple. If you have defined a class, you are the only one allowed to implement certain interfaces, right? And the problem with that is that if I were to create an interface and I wanted to extend that to the string class, I would not be able to do that. In Haskell, you have type classes, and type classes can be extended onto anything, which is great. And if you create a class, you can both implement, but if you don't, then someone else can implement a type class that you either did not want to implement it for or did not think to implement. And the problem here is that you kind of get a king of the hill sort of problem where the first to implement the implementation of a type class wins. So if I implement the show, which is Haskell's toString type class, over some type, and later on in the application someone else does the same thing, or if I update a package and now that package implements that interface or type class, then that's a compiler error. And so that's kind of like the problems with being able to extend type classes or interfaces arbitrarily, is that at some point you have to declare, if you ever get to the point where you have multiple implementations, you have to declare which one wins. And ideally, we would want to be able to have a way of saying that I don't care what you give me as long as it fulfills this interface, but at the same time be able to override that implementation if it suits us. And I believe parameterized modules kind of like achieves both of these points. So let's look at how parameterized modules work in practice. So here is the start of a module definition, right? Module, I forgot how to speak English today. So here I define a module called my module, which exposes everything. It imports the string module, and it imports a dictionary. Now this last line here is what's interesting. When I import the dict module, I also pass along a reference to the string module. And it's important to understand here that I'm passing along a reference to the string module and not the string type. And the result of passing along that string is that I get a sort of like specialized dictionary over strings. So I could, on the very next line, import dict passing along the integer module reference, and that would give me an integer dict. It might become a little bit clearer when we see how dict is implemented. So here we can see the dict module. It takes in a key which must match a comparable signature. Now key in this case is a module, and comparable is a special kind of module that defines an interface or a contract. If we were to look at the rest of this implementation, you can see that we define a custom type, dict, that can contain any sort of values. That dict can either be empty, or it can be a node with some value. In this case, it's a key.t, and a key can be any module, which apparently contains a t type. So that's, that's the key of this particular node, and then it has some value. And then you have all the keys which are less than the current key, and all the keys that are greater than the current key. And so if you want to read from this dictionary, then we need some key that we want to look up, and then of course the dictionary itself. And if the dictionary is empty, we can return nothing. If we find a node, then we will compare the key we're looking for with the key of the node, and then based on the result, either return the particular value we're left with, or we will descend into either the lesser than or the greater than keys. The important things to recognize, though, is that we make two references into the key module, which is passed into this dictionary. And we make a reference to the key t type and the key compare function. If we look at how signatures are defined, this is how comparable is defined. And essentially what this means is that any module is comparable as long as it has a type alias t and a function compare which takes in two t's and returns an order, less than, greater than, equal. If we were to look at this again, right, when I call import dict string, you can imagine that we're essentially copying the entire file you're looking at right now and replacing every reference to key with string. And as long as string contains a type alias t and a compare function, that will work. So that's like the big thing for Gren 04. And essentially the way you know, what we're bringing to the table is a way of creating dictionaries that can work on any key, not just the built-in comparable ones, but any key. And of course, you can use the same things to define hash maps, or any sort of collection type you would want. You may even use this as a sort of like dependency injection sort of thing. You can use this to swap out implementations where you would use one implementation for tests and one implementation for the actual program. You know, there are many ways of taking this, of using this. And I think this would be a very, very worthwhile investment, worthwhile feature. Now looking ahead to June 2024, that's the ideal time to release Gren 05. The interesting thing about Gren 05 is that the goal is to make as many breaking changes as I possibly can. And the idea behind this is that from Gren 05 and out, the point is to stabilize the language. And so I already have a plan for what Gren 01 will sort of look like. And I'm trying to fit all the breaking changes necessary into Gren 05. Now that doesn't mean that, you know, Gren 05 will essentially be Gren 10. It just means that every syntax that I know I will have to break, I will try to break them. That doesn't mean that all the language features that will be in 10 will be defined in 05, but the syntax changes required for those features will be made. So an example of this, I will try to remove all the built-in type classes that we have inherited from Elm. That would be the comparable, number, and appendable. Those will just be gone and instead be replaced with some sort of parametric module or concrete functions. Operators in Gren are currently functions, and several of them rely on those built-in type classes. And so we're going to have to change how operators work as well. And the actual thing we're going to change is to make those syntax sugar. We're going to talk a little bit more about that on the next slide. Custom types will become structural and introduce a common syntax for aliases. So essentially, we're allowing you to define custom types as aliases, and there will be like an inline syntax for defining anonymous custom types, with the long-term goal of them becoming structural, just like records in Gren are structural. And then finally, we're going to allow type aliases to become opaque. Currently, there's no way to do that in Gren, but we're essentially going to say that type aliases, just like custom types, can be opaque types. But let's return a little bit to operators. Now, operators is something I've struggled a long time to figure out a good solution for. So currently in Elm, you are not allowed to define operators. Like the language has syntax for defining what an operator does, but regular users are not allowed to define operators. Only the language author in practice can define operators. Now, and the reason for why operators are kind of like locked down like this is because operators are cryptic. So like here's an example. What does the pipe dot operator do? And without knowing any more context, you have no way of answering that question. There is nothing to really make a guess. There's really no basis on which to make a guess even. Like there's no readable name here. And that's really the problem with operators, is that they allow you to write very succinct code, but they also rely on you to, you really have to do a lot of research in order to really understand what the meaning of an operator is, and you know, how an operator works together with other operators. They're essentially a very, very cryptic feature. And of course, another problem is that having one entity that can define operators while others cannot, even operators that are just as cryptic as anything else, feels unfair to a lot of people. And so a key design goal when changing operators is to find a way that feels fair and avoids the same pitfalls. Meaning trying to avoid operators which are too cryptic. And you could say that, why have operators at all? We can just do functions. But really, I think, there are certain operators that everyone knows, like mathematical operators. And if you want to, convert a mathematical expression to Gren, it would be preferable to do that using the same language. And it would be beneficial because everyone knows math, or most people know math, and they know how the operators work. And so I think we should have operators, but we should perhaps lock them down even more. Like only allow reasonably common operators that people have a reasonable idea of how they work. That being said, it would be very nice if we could, provide our own implementations to certain operators. Like if you were to define a money type, defining how you add two money types together would be, a reasonable thing to be able to do. So my solution to this problem is essentially just to let operators be syntax sugar. So when the compiler comes across an expression like 1 + 2, it is now the same, and I mean it is exactly the same as the function called plus with the arguments 1 and 2. And you may ask, like, what is plus? Where is plus defined? Well, it isn't. The compiler just changes 1 + 2 into the function called +1, 2, and whatever plus function is within your current scope, that's the plus function that is activated. So if you import the plus function from the int module, then you will perform an integer addition. If you have the plus function from the money module, you will add two monies, whatever money is, together. And so that's, very shortly how that is going to pan out. I also mentioned that type aliases and custom types will change a little bit and become a little bit more equal. And so before, you could see that you have to define an alias by writing type alias, name of the alias, and then what is that name and alias of, and then you can create a custom type by just writing type choice and then equals yes or no. The pipe operator is read as or. However, starting from Gren 05, the idea is to simply allow you to define a type by writing an uppercase name followed by the colon and then whatever the type is. And essentially the way you read this is name has type string, or choice has typed yes or no. You can see that we start with a leading pipe in the context of choice there, and that is simply because we have to have a way of separating a choice from any other type of alias. And the idea is that maybe not in Gren 05, but definitely in later versions, you should be able to just make a reference to yes or no. The name is actually an alias. It's not of any other consequence. Another thing that would be nice to have in Gren 05 would be pattern matching over multiple values. So instead of using a record, as I showed before, you would just write, A, comma B, and then you can pattern match on that. And that is just like, I mentioned that, tuples were a refactoring nightmare in a way. And this kind of like here you have the same positional semantics, but this would be a very local change. So if you were to introduce or reorder these things, yes, you would break the code, but you would only break it in case of the case expression. And so it's fine, right? As long as it's about local things, then having a little bit of brittle code isn't that big of a deal. As long as it doesn't spread out to the rest of your code base, prioritizing compact code is okay. So now we've essentially talked about all the things happening in the next, 8 months or so. But after the 05 release, my plan is to take a break. And this is not because I'm tired or bored. This is essentially a way to give me time to evaluate the changes that has happened up to this point. Because up to this point, I've essentially just worked with the compiler. I haven't really done a lot of Gren stuff. And so it would be nice to actually use Gren for a side project, or maybe even write, you know, a syntax highlighter for, you know, maybe write a tree sitter plugin for Gren, and then use Gren to make a game or a tool, a single page application tool, or a node.js command line application, or maybe start writing Gren in Gren, just to get a feel of the changes that has happened up until this point. And so because of that, like, you know, the results of that evaluation, however long that would be, could be that I regret certain features and want to make changes. So I don't know when 06 is going to happen. I know it will happen, but I don't know exactly when. I'm going to take a break from the 6-month release cadence at that point. But something that I'm pretty certain will make it into the language before 1.0 is that ints will be limited to 32 bits. So currently, integers are JavaScript numbers, which means they are floats. And that means that integers in Gren essentially have a precision of 53 bits. If Gren will ever target WebAssembly, and that is the idea, then ints should be 32 bits wide. And there are ways to ensure that. And I think it would be a good idea in order to later be able to target WebAssembly to limit it before 1.0. In addition to that, there are other preparations that we might have to make in order to safely move over to WebAssembly post 1.0. But exactly what those things will be, I haven't gotten a full idea of yet. Another thing that I'm reasonably certain will make it in is a sort of way to expose everything from a module, but in a local context. I got a slide on this a little bit later that I'll show you. And then, of course, carry on the work of extending what you can do with custom types. So with 05, we've made custom types look like structural types, and the idea is to actually make them into structural types, the same way that records are structural types. Then we need some way of dealing with concurrency, and it would be nice to finish the code formatting tool that is currently built into Gren. So let's take a closer look at the local expose all syntax. So this is the problem that we're trying to solve. There's a tool in Elm called Elm CSS, which essentially is an API for defining CSS styles for Elm applications. And you can see here that it is pretty common to make use of fully qualified names in Elm, and especially with the Elm CSS library. I prefer qualified names because CSS contains a lot of definitions, and a lot of those words are quite common. And so I wouldn't want to clutter my own namespace with every single word that's in CSS. The chances of a name being taken is just too high. And so I tend to fully qualify every single reference to CSS when I write code. But in this particular case, I'm defining a CSS style, not a style sheet, but just, this is a CSS snippet. And in that case, it is painfully obvious that everything here is going to be like a CSS reference, or at least almost everything here is going to be a CSS reference. So the idea is, it would be nice if I could expose everything from the CSS module as long as it was scoped to this definition. And that's the idea. So this is what it could look like. You do like a reference to the CSS module, and then you use parentheses to essentially say that everything between these parentheses work as if I had exposed everything from the CSS module. And that would allow us to kind of like obtain clarity, like what functions am I actually referencing, but at the same time not like bleeding those all those names to the entire module. Another example is how this could play out with operators. Like, so when operators are syntax sugar for arbitrary functions, it would be nice to be able to kind of like define addition over floats and addition over ints in the same module. So maybe you had the int plus and int multiply functions exposed to your entire module, because most of the time integer addition is what you're going to do. But maybe you would want a single float expression somewhere. And that way you could use this local expose all syntax in order to kind of like say that for this particular expression, I am referring to float plus and float multiply instead of the integer ones. So as I said, we wanted custom types to be a little bit more functional before we reach 1.0, and this is an example of how that can work. So here we pass in a custom type, or what I've started to call just tags, to a function, and you can see that the first value of that union is a generic variable, and essentially means that this is a partial union of tags. So this function will work on any custom type or any union of tags as long as that union contains 1 and 2. And then you can case over that and essentially say that if it isn't 1 or 2, we're just going to return a string other instead. It also occurred to me that I haven't mentioned that some of these syntax may look very... never mind. Yeah, so that's flexible union tags, or tags of unions of tags. We also need to figure out concurrency. Like most likely Gren will use an actor-based system for concurrency, and this is partly because Elm almost already work this way. If you look at how the init and update functions work, they're essentially ways of defining an actor, where the init function returns the initial state of the actor and the update function defines how to react to incoming messages, and the subscription function essentially allows you to listen on some other actor. And so there's already partial support for actor-based concurrency in Gren as a benefit of being based on Elm, but it's not entirely finished. Like, you can't actually define actors which run in their own space and time sort of thing. You have something called effect modules, but effect modules are limited to core packages, and they aren't really, there are several rough edges there that would be nice to smooth out. For achieving actual concurrency, we will probably have to base whatever feature we come up with on web workers, but web workers has some challenges as well. So for instance, you can't pass any sort of value between web workers. Like, you can't pass functions, I believe, or function references between web workers. And we need some way of, maybe we just define a new type of API that requires that you send not values but bytes or something, and you have to pass in a decoder or something like that. I'm not entirely certain on the details. What I do believe, though, is that we can make web workers easier to work with in Gren than in JavaScript. That we can essentially use the compiler to fix a lot of the boilerplate inherent with the web workers for you, and of course make that portable over to Node as well. So no matter if you're targeting the browser or Node, we will create a concurrency system that works the same either way. So those are the things that I'm pretty certain will make it in before 1.0. But there are things that I already know that I'm going to look into after 1.0. And perhaps the most important thing is who's going to take over after I'm done. Which is not to say that once Gren 1.0 is released, that I'm going to stop working on it. I will continue working on Gren as long as I find it interesting, and I expect that to be a very long time. But I think in order to be a successful language, there needs to be some plan for what happens the day that I'm gone. And so that will be one of the most important things that I'm going to look into once the 1.0 version has been reached. Other things to look into is WebAssembly support. I think we can make Gren a lot better if we have a stable or a better compile target in JavaScript. I think we can make the performance better. I think we can use memory constraints. There are a lot of things we can do if we target WebAssembly. It's not going to be easy, but I think we can make things better. A long-term goal is also to write Gren in Gren. And this is an important thing to me. Like, first of all, I'm not a huge fan of Haskell, which is what Gren and Elm is currently implemented in. But I also think that as a language designer, it's easier for me to be a good language designer if I feel the same pains that the users of Gren feels. And the best way of doing that is to actually be a user of Gren myself. And then finally, I want to look into some way of generating code for common functionality, like defining equals functions, hash functions, toString functions. Writing those sort of functions can get tiresome very quickly, and it would be nice to automate at least some part of that without losing the flexibility or losing how easy it is to define your own functions. Yeah, so that's what I had. So like in summary, the idea is to bring parametric modules around Christmas, and that will be like the biggest change between Gren and Elm, and I hope that will really make people more interested in Gren. That will open a lot of avenues that hasn't been possible with Elm. And of course, we will continue to explore APIs to make Gren a better backend language. And then for next summer, we are going to make many breaking changes to the code. But after that, the idea is that the language will gradually become more and more stable and more fit for production use. So when will Gren reach 1.0? Won't happen this year. It definitely won't happen next. We might be 3 years away by my estimation, at least. But already starting next year, it will become more and more stable and should be of more and more interest to other people. Yeah, so that's what I had. I hope it was interesting. I hope it was worthwhile. If you want to look more into Gren, here are some references to the website, the Mastodon account, and also a link to the example projects that shows you how to write Node.js applications, browser applications, and other things. Thank you for watching.